is going into the aspect of talking about the technical intricacies of using the tools that are involved in DevOps. So the outline for this particular session, I will try as much as possible to make it very brief, straight to the point without wasting any of your time, because we've stayed far here this evening. We'll be talking about what is DevOps. We look at the software development lifecycle, look at the reason why we use DevOps, look at the DevOps lifecycle itself, and look at the benefit of DevOps. That will be the conclusive part of our session today. So what is DevOps? DevOps integrate developers and operations teams in order to improve collaboration and productivity by automating infrastructure, automating workflows, and by continuously measuring application performance. So now all those big grammar is trying to explain to you that DevOps on its own is a way by which we automate development and operations process. The word DevOps is coined from two words, namely development and operation. That's why you have the dev for development and the ops for operation. So it is the coining and the coming together of this word that gives us DevOps on its own. DevOps is a software development approach that gives us room to build faster and more reliable applications. So it will not be, there is no way we can talk about DevOps without talking about the software development lifecycle, because even DevOps on its own has its lifecycle. So DevOps also, before I go into the SDLC, which is the software development lifecycle, DevOps is it allows organizations to also serve their customers better. In what way? It gives them room to develop products and ship products faster, and also gives them room to focus more on developing new features for the application than just reiterating over making corrections that might just be done in a way that will be seamless. Going over to software development lifecycle, which is what I call the SDLC. Software development lifecycle is a project management model that defines the stage involved in bringing a project from inception to completion. So the whole project cycle, from the idea springing forth to shipping your product to the end user, that's the software development lifecycle. So the software development lifecycle, as it stands, it consists of various stages, and I'll be talking about five different stages here: the planning stage, the problem definition stage, the designing stage, the building stage, and the testing stage, and the deployment stage. That's six different stages, right? Not five. So for the planning stage is where the requirement of all the all the software, that's the requirements, the associated risk, the cost, and the customer needs are analyzed and taken into consideration. So before you go into developing your software, you look at what exactly you want to build, the requirements involved, the risk associated. That's where you consider your benefits to stroke risk ratio, and also the cost. So this is all about doing a feasibility study for your app, for your software. That's what the planning stage entails. Now for the defining stage, this is where you define the perfect. You have the exact definition for your problem. Before you can start providing a solution to a certain problem, you should have an understanding of what the problem entails. So the defining stage is where the requirement and the problem statement is clearly defined and documented for you to say, okay, now this is the problem that we are exactly going to. This is our exact focus, and this will also be documented so that it will make the whole software development process easy, and we'll have people that will be accountable for a particular action in the whole software development process. We have the designing stage. In the designing stage, the requirements are documented. The requirements that are documented earlier in the previous stage are represented in architectural format, in which all the components and modules of the software are represented with the data flow between them. So the designing stage is where you have your the problem and the plans that you've made. You actually bring it out in a format, in an architectural format that shows your data flow, that shows your flow chart, and explaining how different components and different modules of the software communicate with each other. Then we go down to building stage. building stage. Building stage is where the design software is developed. So this is where your developers dig in, get their hands dirty. They use their favorite tool, their programming language of choice, and they get this software up and running. Now, the testing stage is where the software developed is tested for issues, and the issues are being fixed. So the testing stage is a very important stage. This is the stage where you call in your testers to come and check your application, and they run it through. They pass it through some tests to actually determine if it is marketable or not, and if it has any issue that needs to be fixed. Now, going over to deployment stage. The deployment stage is the stage where the software is released to the market or customers for their use. Developing your application, it is actually for a particular and for some group of users or for a particular market. So after the software has been developed and it has passed through all the 5 stages listed above, from the planning to problem definition to designing to building and through testing, and the last stage is a deployment stage. Now, in the deployment stage, this is where you push your software to the market that it needs to be. You are developing an Android app, you are looking at the prospect of pushing your Android to Google Play Store, getting the link across to the right audience, and probably running some adverts to get your app across to the targeted audience. So now, why do we need to use DevOps? DevOps helps us in moving away from disconnected environments to a more cohesive and synchronized one. One with the common objective of delivering high-quality software with speed. DevOps shortens the software development lifecycle while delivering features, fixes, and updates frequently in close alignment with the business objectives. So, other than DevOps, there is a particular A particular software development methodology known as the Agile methodology. So, in the Agile methodology, it is part of the software development lifecycle models that I just explained earlier. Other forms of model include a waterfall model, iterative model, spiral model, V model, Big Bang model, as well as this agile methodology. I'm not going to go deep into that because that's not our focus for today. But just a brief analogy. The whole concept of DevOps is having your developers and your testers interacting seamlessly with the IT operating team. So the developers are in charge of developing your features, developing your softwares, and pushing it to the developers and testers. They develop the software, they test it, and they push it to the operations team. The operations team are in charge of managing your servers, your infrastructures, your networks. They look at the scalability of your app, of your software. They look at providing data backups for your softwares. So that is their own work. Now, for the relationship between the development team and the operations team without using a DevOps methodology in software development, it is going to be one in such as once the development team has probably released the feature and they pass it across to DevOps team, and DevOps team now look at the feature that they developed, saying that it has one or two problems that might affect scalability or might not probably be shipped along with the present release. They will send the work back to the development team. Now, if project manager now comes into play asking what's wrong, why is this feature not available yet, you have some sort of blame game that goes on between the development team and the operations team. So the reason why we have DevOps is to prevent such blame game. It bridges the gap of communication between your development team and the operations team. So DevOps is an essential part of software development in the modern day software development methodology. IT companies are migrating from traditional culture of having a straightforward development and operations to a culture that focuses more on collaboration between the development team and the operation team. So this culture that focuses on a centralized view across different projects, across a particular project, it helps to overcome the challenges and complexities of a faster release cycle, so that when there is a perfect communication gap between your development team and your operations team, it will be very, very difficult. It's very, very easy, rather, to monitor the stages of features that are the different stages of features that are released by the operations team. So the DevOps lifecycle, I'll be going over to the DevOps lifecycle. The lifecycle that I'll be talking about in DevOps is split into 5. We have continuous development, we have continuous integration, continuous testing, continuous deployment, and continuous monitoring. Now let's look at each of these development lifecycle bit by bit. The continuous development lifecycle is the stage that involves the planning and the coding of the software. That's the continuous development stage. It also includes the use of maintenance of the code with the use of version control system tools. There are several version control system tools such as your Git, your Mercurial. They help in versioning your code. And when it comes to version control system, we actually have a centralized and decentralized version control system. So the continuous development is actually about planning and coding the software. Now moving over to the next stage, which is a continuous integration. With continuous integration, your team compiles software and run it through a series of tests that mimics production environments to ensure that a successful build when pushed to production. So what happens in a continuous integration is that the response to problems in the traditional deployment lifecycle, they are practically solved here because they make sure that what you are pushing to production is actually a version that has been thoroughly tested and it has passed through both the testers at the development cycle and some series of tests at the operations team end before this this release is pushed into production for the end user to use. There are popular tools used for continuous integration, and some of them are Jenkins, TeamCity, and Travis. Jenkins is an open source integration tool. It allows developers on their own to integrate code branches during the development process and also run different series of automated tests against them. Jenkins operates with, it runs in Java. Then TeamCity is, I think TeamCity is from JetBrains, if I'm not wrong. And TeamCity also helps in continuous integration. Now going down to continuous testing stage. In the continuous testing stage, this allows for continuous testing of the software for bugs with the use of automated tools such as Selenium testing, Jenkins, and JUnit. So the testing stage is where you make sure that, okay, this particular software is free from bugs and there is no sort of error. And if possible, there's an error, maybe an error is found, we are all humans, and the developers working on some of these stages are also humans that are prone to error and prone to make mistakes as well. So, but that notwithstanding, the continuous testing stage is the particular stage where all these bugs are fished out, issues are identified, and they are fixed before they get to production. And even if I thought there's a version of it already in production, the fact that this process is continuous makes it easy for this release to be pushed back, for these fixes to be pushed back into production instantaneously. So we have Selenium as a portable software testing framework. I think that one is used mostly by web application, and there is Selenium ID that's the Selenium ID is used with a particular test domain. And that one is called Selenium also. Then Jenkins and JUnit are also used for continuous testing. Now going down to continuous deployment. In continuous deployment, this is the stage where the code is deployed to the production environment and ensures that the code is correctly deployed on all servers. This stage consists of your configuration manager and containerization. Okay, before I talk about containerization, let me quickly just give a brief definition of configuration manager and containerization. What is configuration manager? Management, rather, I said manager, please pardon me. Configuration management is the process where a configuration platform or tools, such as your Chef, your Puppet, your Ansible, are used to automate and monitor design. They are used to automate, monitor, design, and manage manual configuration processes. I mentioned some tools here. Chef is used to automate infrastructure provisioning. It's used to deploy and manage server and applications, and both in-house and on the cloud. Whether you're having your infrastructure on premise or you are using a cloud solution, you can use a Chef to automate your deployment and manage the servers. We also have a Puppet, as mentioned earlier. Puppet is mostly used on Linux and Windows OS, and Puppet is actually used to work on multiple application servers at once. So Ansible is also another tool used in configuration management. It allows you to create different groups of machines and describe how these machines should be configured and what action each of these machines should be able to do and what action should be taken on them. So that's about configuration management. Now down to containerization. Containerization is defined as a form of operating system virtualization through which applications are run in isolated user spaces called containers, all using the same shared operating system. Docker and Vagrant are popular tools of containerization, which help produce consistency across the development staging and production environments. I want you to think of containerization as what the word stands for exactly. Now, once you have a container, like if you have a container, you can use it to actually ship multiple items. Instead of you to be picking your items on hand one by one, you can have several items inside your container and ship it, use it to package and move your items together all at once. I mentioned some tools here that are used in containerization, Docker and Vagrant. Vagrant I think Vagrant is focused on providing a consistent development environment with multiple OS as usual. And yeah, Docker does that too. I think Docker is more lightweight and it's kind of it's a software package, is standalone. So that's that about the continuous deployment. So going down to continuous monitoring. Continuous monitoring is a very crucial stage in DevOps. So in the continuous monitoring stage, this stage is aimed at improving the quality of software by monitoring its performance. The operations team monitors the user's activity for any bugs or improper behavior of the software with the help of tools like Splunk, ELK Stack, Nagios, New Relic, etc., etc. So here, these tools are actually used to monitor the application and the server closely. So they have to check on any issue, and as soon as any issue is found at this stage, it is reported by the operating team back to the development team and fixed in the continuous development phase. Then from the continuous development phase, it is now passed down to continuous integration, continuous testing, and back into production. So and that issue is fixed. Now, these stages are carried out in loops continuously. That's why it is said to be continuous. If you look at the software development, software development lifecycle on its own, you have your planning, your design, your planning, your defining, your design, your building, your testing, and your release, your marketing the product. But one major thing that you should observe about this thing is that it is not written as continuous, as something that happens continuously. It actually happens at interval. Now, with agile methodology, it is very, very easy to actually work fast and probably have a feature release or probably product release and bug fixes in every 2 weeks. But with DevOps, you are actually having this thing in a continuous loop. All these DevOps lifecycle stages that I've listed and we've mentioned that we've discussed, they are in continuous process. They are occurring one after the other. It's like an infinite loop that runs continuously until the desired product quality is achieved. And we have a satisfactory product on the end of the user, and the development and operation teams can probably relax and say, yes, they've done a very good job. Now, let's go down to look at the benefits of DevOps. DevOps helps to increase the rate of software delivery by improving the company's time to market, potentially from months and weeks to days and hours, because the whole life cycle is in continuity. It's a loop that runs continuously. So it also helps to maintain better business structure by automating their infrastructure. It saves costs on maintenance and upgrades and eliminates unnecessary capital expenditure. It helps to improve quality, reliability, and reusability of all system components. It also helps to unite team and standardize process for easy replication and faster delivery. Now, when you have your developers team and the operations team working hand in hand, it will be very, very easy for the the operations team to inform you of any problem that is going to be coming up or getting wrong with your with the software that you are planning to send across to them, even before you get to the stage by which you send it across to them, and it will now be returned back to you, and you'll have to start work from it from the beginning. These are things that might actually slow down your productivity, slow down the the time taken to deliver the project. And having DevOps, it serves as a means to unite both the development team and the operations team and we have a standard process that makes software delivery very, very fast. So this is where I draw the curtain on my introduction to DevOps for this evening. I believe I've not been able to take too much of your time. And if at all there's any question, I believe you all are going to ask me your question while I answer them. So thank you all very much. I appreciate your time.
Yeah, thank you. Thank you very much. We really appreciate your presence, Mr. Boluwaji Akinsefunmi. Thank you very much. And our first facilitator, Mr. Dolapo. Thank you very much. We appreciate your presence and your effort. You've been pushing so far. Thank you. Please, if you have any questions, can you please pass it across so we can all end this program? Anyone, please raise your hand if you have any questions. Do you have any question, please? Hello, do you have any question? I don't think anybody have any question.